So I received this email with the subject line, malware analysis, and it reads, "Hello, I've watched a lot of you videos a while ago. I program as a hobby and came across your page with the cybersecurity and loved it. I just did something not so smart. A fake CAPTCHA popped up and asked my to open the run dialog box, paste and press enter. I was moving too fast and didn't realize, noticed a weird file on my computer afterwards. Will you please have a look?" And they include the code at the bottom of the email, and now we can open it up and see what it's doing. Now I am inside of a Windows 11 virtual machine, and I have the file contents that they shared inside of this file called cloudflare.bat. They explained later in the email this was the name of the file, so we can open it up in a text editor of our choice. I'll use Sublime Text. Opening up the cloudflare.bat file, we can see this has all the same nonsense and noise that we just saw previously. If you aren't familiar, the .bat file extension means this is a batch script, or the scripting language for the shell system on Windows, Batch. The very first line is nothing fancy. This is the usual default kind of boilerplate thing that you see at the beginning of most batch scripts. The @echo-off syntax is disabling echo so that it won't show all the commands or syntax that's ran as the script executes. So while we start to clean up this file, let me save a copy for us to maintain our modifications. We can just say modified.bat for a batch script. We're not too concerned about the @echo-off line, so we can remove that, but the next line is pretty lengthy. In fact, the entire script is pretty lengthy. I don't know if you can see on the right-hand sidebar, but scrolling down, this is a lot of stuff. Just over 500 lines of seemingly nonsense, but we can make some sense of it. But you've probably noticed a certain pattern. It looks like, for lines 5 and onwards, they all start with some sort of nonsense or gibberish. And then at the end of the line, some string wrapped in double quotes, all syntax highlighting and marked in yellow. Let me actually enable word wrap so we can make sense of this very long line now at the very start. And from there, you could probably see the pattern or another pattern sort of continue. This KGKCCWBGR nonsense is repeated over and over again, wrapped with percent signs, just following maybe the letter S, or the letter E, or the letter T, and so on. If you aren't familiar, variables inside of batch are actually accessed to retrieve their value given the syntax wrapped in percent signs. So I could set a variable to a value, and then I would echo to display the value of that variable, wrapping it with percent signs. But if you were trying to reference a variable that does not exist, then it won't actually display anything. At least from the command line, in the interactive prompt, it'll include the percent signs wrapped around it. But if this were to be executed and ran from a script, just as an example, we can create our own test.bat, where we will do that very same @echo-off, but then try to echo the value is for a variable that does not exist. Saving our script and then trying to run it, it won't actually display anything there. The value is nothing, because it's not set. So back in our code that we are looking at, this KGKCC big long variable isn't set to anything within the context of this script. That means it will evaluate, wrapped in percent signs, to nothing. And it's basically not there. We can then find and replace and remove all the occurrences of it. So we'll see something eventually actually creating the syntax set local enable delayed expansion. Now, if you aren't familiar with batch scripting, delayed expansion means that the variables will be evaluated at execution time, not parse time. It also introduces a new way to represent variables rather than wrapped in percent signs, but actually now wrapped in exclamation points. And we'll see that syntax later on for the other long, strange, random variables, H, X, B, J, A, Y, etc. Now I'm going to actually turn word wrap back off so we can see the other lines as they were. And now that we've made sense of this first line, let's take a look at what were lines 2, 3, and 4, before it got to that pattern from line 5 onward of using that HXBJAY over and over and over again. Looks like line 4 sets a big long variable name DNPA, etc. to just the value S. So once again, we could simply change that with find and replace, just knowing that, hey, that's supposed to represent the letter S. Line 3 has another variable set to the value of t, so let's change that, just so we could keep track of what these all really should represent. Line 4 now does something really interesting. It looks like it sets that big long variable hxbjay, etc., to the value of the variable that was referring to the letter S, and then the other for referring to the letter T, with a literal E in there to build out the word set. Literally the syntax to create or define a new variable. That means that all of these lines down below are setting other variables. Let's do our find and replace as we have just previously, but let's actually include the exclamation point beginning and end of our find, so we can replace that with just the word set. Now, lines 5 and onwards are pretty clear. They're setting more variables to more values, all broken up in sort of chunks of 4 here and there. And it does this through basically the entire execution of the script, except for line 167. Which is interesting. That actually has some other random data, it seems, at the very end, but it actually begins with these 2 colon characters. And this represents a comment in batch. You might see other representations where they use rem for remark, but 2 colons works just as well. Being a comment, that means that this line won't actually be executed and ran as code. It is all nonsense. While it looks like base 64 encoding. If I go to the very end here, there is no equal sign or padding that helps clarify and make certain, oh, this could very well be base 64, though it's not always necessary that those equal signs padding are at the end. But if we were to try and decode this, we can keep it simple. I'll just open up Firefox and use CyberChef. On CyberChef, we could go ahead and enter that input and use the from base64 recipe to decode it, but it does look like nonsense, nothing helpful. Perhaps it's some encrypted data, we don't know quite yet. Maybe the code will actually reference this back inside of its own internals and file contents on its own, so we could remove this or we could keep it in our mind, whatever you prefer, but I think for now, let's just remove it. All that junk could still be just trying to add other chaos and noise in the file, so antivirus engines or security solutions won't pick up on this file. Scrolling back down though, beyond that line 167 that we were looking at, this continues to just set content over and over and over again, until, it actually uses an environment variable for the system drive, but then it invokes all of this by concatenating or joining all of those variable values together. Let's turn word wrap back on so we can see that whole payload. And that is pretty hefty, considering it's probably using 500 variables to now put together an actual payload that it runs. Then down below, it has the syntax to exit, probably a command that it would run with, exactly the variables just previously being executed. So this bottom line on 511 is actually exit/b, as you can see that value being used. So ultimately, what we want to do is figure out what does this line, 508 now, really mean? What does it represent? What all code is being ran here as all of these variables are now created just above? Well, it's very likely, if this were malware, which we can assume it is, malicious code being staged and prepared, this ultimately is going to be another trigger, or invoking another payload for like a second stage or another set of malware. So rather than letting this fire or invoke, trigger, detonate, whatever, we'll actually want to just display it out on the screen so that we can see what all of these variables actually mean in the order that they're used. So very simple, all we could do is set an echo here on this line, just to display that out. Granted, this is not a foolproof solution for trying to defuse this malware sample, but it is something that we could try even inside of our virtual machine. Of course, being safe, making sure that this won't fire on any computer that we really care about. But I think we have everything set and staged to just see all of these values now being set in whatever order they are, and then ultimately displaying how they're being put together. We could just run this modified script and have it unravel and show us the real value of these variables all put together in the order that they should be. That will help us get to the next stage. Let's add the @echo off at the very beginning of the line again, just so we don't have to see all these set commands being executed. But now, let's try and run our script. Back in the command line, in our terminal, let's fire up our modify.batch script. I'll hit enter, and there's the whole new payload that we'll fire. Looks like this is actually PowerShell code. And we see it being invoked with PowerShell.exe, -no profile, -window style hidden, and -EP for the execution policy being set to bypass, so it won't even bother with PowerShell's execution policy, and then a command with all of the other syntax down below. That means that this is now PowerShell syntax we can make some sense of. So let's put that in another file and then take a look at that. Let's create a stage2.ps1. Now before we dig into this payload, let me take a quick second to tell you about the sponsor of today's video, Vanta. And I'm very excited, going to be joining Vanta for a webinar on Tuesday, February 18th. If you're willing, you'd love to tune in, I'd love to see you there. We'll be chatting about artificial intelligence and security maturity, and I'm really looking forward to it. There is a link below in the video description if you'd like to tune in. But anyway, let me tell you about Vanta. It's how you streamline security reviews and automate compliance. Vanta is the leading trust management platform with over 300 integrations for your software stack, so you can measure your security controls, match necessary policy requirements, and meet the mandates for audits of your business and security posture. With Vanta, you can automate your progress to meet standard regulatory requirements. And there are so many out there, between SOC 2, HIPAA, ISO 27001, PCI, GDPR, and all the different compliance needs. You can run tests to validate and verify your controls are in place, remediate issues, manage risk, and ultimately prove your security compliance. Vanta allows you to publish a continuous and real-time trust center on your public website, or you can share them personally with customers and prospects. You can even allow auditors to log in themselves and assess your security posture. So at the end of the day, customers know that you are a business they can trust. You can build confidence, streamline your security requirements, close deals faster, and increase revenue with Vanta. Join over 6,000 companies partnering with Vanta and prove your security compliance. Get $1,000 off Vanta with my link below in the video description, jh.live/Vanta. Huge thanks to Vanta for sponsoring this video. All right, now let's get back to stage 2 written in PowerShell. Let me turn word-wrap off for a second so you can see that this is all on one long line. So if we wanted to make some sense of it, we should try to clean it up. What I like to do is actually replacing all of these semicolons that denote the end of a line or some syntax or command that's ran with a semicolon and a new line. So it's a bit easier to see in a logical, clean syntax. Let's do that. Another simple find and replace, where we replace every semicolon with a semicolon and a new line. I do have regular expressions enabled, so I can use that \n syntax. I'll hit Ctrl-Alt-Enter on my keyboard, so this finds and replaces each part, but this might actually be done better within Visual Studio Code, because it has a PowerShell beautifier. While the simple find and replace tricks will work and we could do some manual cleaning, I know it's not as accurate and feature-rich as using an AST or abstract syntax tree. That's okay for what we're working with, but it'd be nice to automatically beautify this. So I'll install the PowerShell module for Visual Studio Code. With that installed, we can now hit Ctrl-Shift-P on our keyboard and type in format to be able to format the document with another hotkey, Shift-Alt-F, if you want to skip that step. That apparently didn't do much for us either, but at least we've got syntax highlighting more than what we had in Sublime Text. Let's try the same usual find and replace just to keep things moving. We can do the same for the closing and opening curly braces, and that will at least get us some more clear syntax. Let's format again with that Alt-Shift-F. Excellent, this is much easier to read. So the very start defines a couple functions. We have decrypt function, which is aptly named and much better than the randomness we saw in the batch code, and we have decompress function. Below that we have execute function, and then some of the actual commands that are ran naturally. A variable srydd set to actually the script that was invoked. Now, naturally, this would have been the cloudflare.bat malicious endpoint, but we had our modified one ending up executing this. And within Visual Studio Code, we can at least have a better change all occurrences of a variable rather than using the find and replace. We can change that to invoked batch script. Just below that, we can see that it uses the PowerShell host variable, another built-in capability to access the hosting provider for PowerShell, where it sets the user interface window title to be that same script. Then it retrieves system IO file, system environment, and other providers within PowerShell that we can again change the name for. Then the line just beneath it, we see another variable set to actually use the system IO file and type provider to call a function, interestingly enough, with the backwards or reverse name. They use this indexing here from a -1 up to -11 to join together it being now properly fixed and returned in its normal order of characters to call what would be, I'm assuming, read all text backwards. Take a look. We can see this in action within PowerShell. We'll hop back to our command line. Let me invoke PowerShell super quick. And then if I paste this in, you'll see that it does ultimately evaluate to read all text. They use this reverse string trick all throughout. You can see it in the code below and in the other functions above, so that's kind of cutesy. But it's interesting, they actually read all the contents of the original script, and then it looks like they end up determining things split on new lines, and then looping through each and every line. We can rename these to have it make a bit more sense. So this loop will actually check if that line starts with, the 2 colons, the comment there, where it will actually get onwards that content. So that was that comment that we looked at within CyberChef, tried to decode with base64, but it looks like it is going to be referenced in this later second stage payload. We can set this to the batch comment for a variable name, and then they actually define this in appropriately called a payloads var, where they split on every backslash, and then they decompress, decrypt, and then work with it from base64. Of course, this being another reverse string. Then it executes what would have been payload 1 as it extracts out, and payload 2. That's kind of clever, because the backslash is not usually a standard character in base64. Typically, you'll see forward slashes and plus signs in base64 encoding, but not backslashes. Now, we don't really need to make sense of the decrypt function or the decompress function or the execute function because, well, they're all pretty clear, right? Execute will end up invoking this as it is a .NET assembly, loading a specific module or function to run. Decompress actually takes it out of the gzip stream, so that base64 content that we saw within CyberChef was likely gzip compressed and actually encrypted. The decrypt function uses the AES, or the Advanced Encryption Scheme, with the CBC cipher mode, padding with PKCS7, and all the keys and initialization vector that we're able to actually obtain. It's all included here in the code. So if we press the I believe button on our decrypt, decompress, and execute functions, well, we certainly don't want to execute them, but we would likely want to dig in and understand what those payloads are. So let's actually change these last 2 lines where they would execute function within the .NET assembly. But we actually want to take a closer look, so let's write the contents of these payloads into a file for us to examine. I'll use system.io file write all bytes, just the function from that file provider we saw previously. We will include the payload, but we also need to give it a name as to what to write it to. Let's call it payload 1, and we'll say this is an exe or a DLL. It could be either, really being a .NET assembly. Since it is loading one specific function to call, I think we'll call it a .dll. We can do the very same for the second payload, and we'll call that appropriately payload2.dll. And with that, we'll close the function call. Now I think we have defused this second stage payload, and we can trust it and run this stage2.ps1 file from our command prompt. Back in PowerShell, let's trust our stage2.ps1. Enter. Oh, did not like that. That's because it's still pulling from our modified.bat script where we removed that commented payload. Let's put that back in. We still have it in the original cloudflare.bat actual original malicious file. So let's grab that line 170, all the contents, and make sure that's something that our script could still be extracting out. Really doesn't matter where this goes now at this point, since we know it'll loop through every line, so let's just paste it into our modified.bat. And let's try to run that stage 2 again. Oh, no errors this time, so it should have written this out to our current directory, given a payload1.dll and payload2.dll, which we can see exists just fine. Now, I'm using the context from this execute function to note these are likely .NET assemblies, or managed code, and this could still be actually investigated with tools like dnspy, ilspy, .peek, and others. We can also take a look at some of the details for these payloads. The DLL file, interestingly enough, in the details section tells us that it is language neutral, and the original file name with randomness.temp. Same thing for payload 2 if we take a closer look. QNXLO whatever. But let me open up .peek and let's see if we can take a closer look at the code inside of these .NET assemblies. Let's open up payload 1 to start. And you can see that's now changed to that DGAWTK whatever. And below, if we drill down into this, we could see the program and the code that it actually runs. I'll double click on this and it should open it up for us to view and take a look. This is, certainly malicious without a doubt. Looks like it's staging enough to be able to run other Win32 API functions, like load library, get proc address, get module handle, and virtual protect. Included here in the main function is interestingly, actually loading the AMSI.dll. If you aren't familiar, AMSI is a feature in modern Windows for anti-malware. Anti-malware scan interface is that acronym where it's going to be looking at code that's ran, oftentimes managed code in PowerShell, in .NET assembly just like this, C#, Visual Basic Script, and all the others to try to look for malicious activity. Stuff that Windows Defender, your default antivirus on Windows, should detect, flag, and remove. But this procedure, what they're doing here, is actually replacing contents of the AMSI scan buffer function, so that it won't actually be able to evaluate or read the contents that it's trying to scan. They're adding new bytes or new opcodes, machine instructions, so that function no longer does anything, or at least it breaks some of its functionality. And it looks like this is all that this payload does. Payload 1 is simply the AMSI bypass. You can see it calls virtual protect to modify the memory permissions on that DLL loaded, and then it patches the bytes of the function so that it no longer works and restores the old memory permissions. I don't see anything else to explore within this DLL, which explains why this was kind of a small file to begin with. But let's open up payload 2. Payload2.dll. Now you can see the name change once again, and that has much more randomness here. Oddly named namespace with an oddly named class and a whole lot to it. So let's double click on this and see if it can make some sense of it. Oh boy. So this internal class defines a set of strings known as links with, actually setting, I'm going to assume, an IP address for Norton.com, Bitdefender.com, TotalAV.com, McAfee.com, all of these set to 127.0.0.1. Just assuming based on, wow, there's so many of these. Can I pull this out? I want to be able to see them all. Let me replace out the /R and /N carriage return new line feeds, so that way we can just see them on separate lines. But wow, it's going through and trying to actually set just each of these domains to refer back to localhost. So the user will no longer be able to actually access any of these web pages or communicate with them because the IP address has now been overwritten in their etc. host file. A bunch of security solutions in here like Cybereason, Webroot, Sophos, F-Secure, VirusTotal, and more. But I mentioned the etc. host file because, well, I see it referenced here, and that syntax, the format of just the IP address and the domain, is likely what they're using to sinkhole these domains and limit connectivity to it. Then there's another function, aptly called kill other PowerShell processes, that does just as you would expect with some PowerShell syntax, and probably easy to see with any EDR worth its salt. It actually just shells out to calling get process and PowerShell syntax to kill other processes. Nice. Then the usual includes for load library, get proc address, virtual protect, and others. And actually setting exclusions for itself. Function here called exclusion that uses the PowerShell commandlet add-mp preference with the exclusion path set to whatever is passed into this function. And again, invoking this via PowerShell. Below we have disable reset. That's kind of neat with reagentc.exe. reagentc is a command line tool within Windows to help with Windows recovery. So if you're to try to do a system restore or reset your machine, well, it's no longer going to allow that. You do need administrator privileges to be able to make those changes, but I'm going to assume in this malware scenario that's already very likely been granted because the victim is probably running as a local admin on their computer. They might not be, but maybe it'll use some other tricks to do some privilege escalation. We can see it references its own namespace to kill other PowerShell processes, disable reset, and then read all lines from the etc. host path, and then add those in. Then it adds an exclusion for itself, as we would expect, get path root, get current process given its file name. Then down below, it'll use another proc address variable referencing the get proc address import that it used for that Win32 API function, and actually, using load library to load in ntdll, but actually the function etw event write. ETW is event tracing for Windows. It's basically another sort of log environment or sort of audit and telemetry source in Microsoft Windows. But they're actually patching out the ability for ETW to write any contents. That's actually neat. I don't think we tend to see anything that disables or breaks ETW in other samples we've seen on this channel. Then they do some other shenanigans, changing memory address, of course, to make that patch and then build out payload.exe. That's actually defined as name1, or a variable set that'll actually reference inside of a loop, where it's finding each assembly that's executing and its manifest. And if the name is not ending with .exe or .bat, it'll skip it. So it's very likely trying to find payload.exe itself and then actually writing contents here, based off of the name. It looks like that's using a function that we haven't gotten to just yet, but then it ends up setting attributes on the name that it finds to be hidden and a system file. And then it starts a new thread to actually, start the process, wait for it to exit, set attributes to normal, and then delete it. So it's very likely hiding and then invoking the payload.exe file, whatever that might come to be. We can see raw assembly being another function we haven't quite seen, with other data that's extracting out. Wow, my goodness. From base64 data that we could try to unravel. Let's put this back in CyberChef and see what it's got for us. Nonsense. Probably encrypted. Same for the other, I'm going to assume. Yep, okay. Likely encrypted. We'll see that more in the code later on. That means it's probably going to have another inner assembly. If this is stage 3, following our stage 2 PowerShell, do we get to a stage 4? It ends up loading the assembly and then invoking it, so that must happen. But how did this name1 payload.exe file actually get written? Did it? What function are we in right now? We're in main. Did I miss a function call somewhere, some here? Oh, yeah. If it is startup based off of something, it'll end up running install startup. Okay, so install startup is what I want to see next, but we do have a couple other functions down below, like, checking if it is an admin, or if it is actually in startup. So some persistence mechanism here, making sure that itself is in the local app data folder and likely the startup files. And here is that install startup. Install startup takes a batch file path given a random file name, random whatever, .bat, combining, it's realtechhub.bat in this case. If that directory exists, realtech hub and local app data, then it will delete files in it. Otherwise it creates it, and then it combines what would be string 4, the current path, string 1, which is the random file name, string 2, another random name, plus string 3, .bat. Okay, so that creates a totally random batch script, not our original cloudflare.bat that we started with. Okay, and then it invokes it with wscript.shell based off the destination file name, writes contents to make sure that that is present on string 5 to make a Visual Basic script. Then it validates this thing is an admin. If it is, it'll try to start PowerShell to create a new scheduled task for Realtek Audio being the name. QC. That creates a trigger for upon login, and then that scheduled task actually executes string 5 being our Visual Basic script file. The Visual Basic script file is what triggers and invokes the previous destination file for the batch script. So that is what is ultimately triggered by this persistence mechanism scheduled task. And they have this hidden as the window that gets opened. And then down below, they also have, and of course, the Windows registry run key, where they have another Realtek Audio entry here to use wscript.exe and invoke the Visual Basic script. Goodness gracious. Also have another function here, get scheduled task by name, that uses some WMI, or the Windows Management Instrumentation, to search for, the scheduled task. Probably just to validate it actually created it successfully and doesn't need to create it again. Just a convenience function. Then we have the other nonsense with encryption. This ZTSLP whatever function will do the very same AES advanced encryption scheme with the usual CBC mode, PKCS7 padding, creating a decryptor based off the key and input and value that are all provided. Another following does the gzip stream, just like we saw in PowerShell, and another ends up executing yet another assembly. But that is the end of this, so where do we fire our next payload? I want to scroll back up in the code to see if I missed anything with the assembly. And oh, here, our raw assembly variable is set to the namespace with the, what is this, the decryption function? Oh, the DMFX one that they're calling is the gzip one. Following onwards, we can see the other that actually uses the ZTS one. I believe that was the AS encryption. Then namespace again, calling for the SSFV based off of name1, and that's our payload, payload.exe. Oh, so that actually executes it based off of the current executing assembly with a resource stream, manifest resource, copying it to, the name that it includes there. Does that mean that it is included like as a resource for this file? And then it's all set up to trigger and execute? Scrolling back to the line, yeah. Okay, after it decrypts it based off of the initialization vector and key that are provided to those other functions, after they're decoded from base 64. Ooh. All right, so what is in our resource section? Do we see anything weird? Payload.exe, right there. What's the contents of this thing? No, don't open it, please. Dear God. Let's just save resource to a file. We can call that like stage 4 payload.exe. By the way, I do have Windows Defender totally nuked. The antivirus is not going to flag or trigger on this for me to be able to showcase and walk through the video. But obviously, I'm hoping Defender would probably catch all these shenanigans. So let's actually try to work with this within CyberChef. Let me upload or put in that stage 4 payload.exe. And now let's try to do an AES decrypt, where we can specify a key and initialization vector with base 64. Let's go grab those from the code. I believe the key comes first in the call to the AES decrypt, so let's grab that value. Let's enter that for our AES decrypt, and now let's get an IV, the initialization vector. And now this errors because our input it thinks is being provided in hex, but no, it is literally the raw output. And there, okay, now we have all this. So that is still gzip compressed, right? That's what the other following function would actually work with. The first function retrieved the value from the resources. Then we AES decrypted, and then we decompress the data. So we do need to gzip deflate. I think we can gunzip, right? Or gunzip in CyberChef. And now, there we go. We have an executable file, payload.exe. Let's save this and let's download it. Put this on my desktop. Now we have payload.exe. Let's take a look. xclient.exe. You mean Xworm? The rat and remote access Trojan? That is on its own a .NET assembly, so we can open that just as well within .peek. But it's not going to be anything fancy, right? It's just xrat. You can see the name here, xclient, where you have other namespaces defined for my stub and others. But now we do have all of the configuration values there, the settings for the host, port, key, and all the things that could be necessary to determine how this client connects. And we can explore all the others if we'd like. My application, nothing fancy. My computer, nothing fancy. My project, looks like it ends up kind of staging all of these values. I don't think we really need to fall down the rabbit hole for just another, hey, off-the-shelf kind of commercial remote access Trojan. What's the stub look like? AES decrypt is as you would expect. Client socket is just simply making the connection as you would expect. But sending info back and forth is still kind of neat and kind of cool to be able to see all the capability that it has. Like spreading, you can see another function for UAC or the user account control, how they might either check if they are an admin. Looks like determining the antivirus engines, all the information gathering that it will try to retrieve from the victim that's connected and how it uses this for command and control. You can see a helper function that includes a couple of the default strings, stuff that it'll end up using for its back and forth communication. User agents, hey, input time, last action or activity, all this flat, classic Xworm. And main function does all this as it decrypts these settings and uses these to end up making its callback and connection. I am most interested now on what actually this calls back to, although there are a couple really interesting things like running anti-analysis trying to determine whether or not it is inside of a debugger, like detecting a sandbox, etc. Even a check for any run, neat. Yep, checking if it's going to be run within inside of a virtual machine like VMware. All the things to do anti-debugging so that security researchers and other folks won't actually be tracking down, this is Xworm. The messages section, you can see all of the sort of protocol that they have for communication back and forth, capability for whether it's going to be working with commands like shut down the PC, restart, run shell commands, etc. Uninstaller, other capability, even in the messages section. There's a lot of code here, a lot that is vanilla, kind of typical Xworm that I don't think we need to go through. It is very funny, though, to see a lot of the, like, not to say low-level or high-level stuff, but when it's calling or shelling out to PowerShell or command line DOS or batch, etc. This is a keylogger. Wow! Of course, Xworm has that capability again, so nothing fancy there. But what does this connect to? Let me get back to the settings. We have these values here, so we could decrypt these. It's calling algorithm AES based off of a given key. Oh, and that key is actually determined by a destination array variable that starts as nothing, but then gets filled out based off of a computed hash from helper.sb and the mutex. The mutex is defined in settings, which is this. So what does helper.sb do? Is that just string to bytes? Yeah, it is. Okay. SB encoding is just converting that to bytes. So crypto service provider is just the MD5 crypto service provider, which I'm going to assume is going to take an MD5 hash of that mutex. And that's just going to be the key. Let's see if we can play with this within CyberChef again. Let me enter that mutex name. Let's MD5 hash it. Now we have this data. That is 32 characters, though. How does that get converted well to be just 16 bytes of the array? Oh, well, it is 16 bytes, though, as it is 32 characters. But if the code puts it in the destination array at the first position and then the 15th position, then it's going to end up clobbering what would be the last bytes of the 75 hash, right? So it'll end at 5cc, but then kind of losing that last bit. I think we now actually have the value, and let me remove this MD5 just so we can see our input. It is this, without the trailing 42. Now that we know the key, we could decrypt with Ridgendale Manage in ECB mode, a decryptor based off the input. That should still be AES, right? So we AES decrypt a key given this in hex in ECB mode. Do we have an initialization value? I don't know if we do. And then the input, which is provided, given our settings of our hosts, that's what we want to decrypt. Put that here. That we still need to base 64 decode. So from base 64, drag that to the top. ECB input is raw. Are we accidentally clobbering a key value there? No. Unless 00 is at the end. Oh, it is null bytes at the end. Excellent. Okay. So, and then there's no initialization vector. We have that decoded, and now we know the host. And now we can do this and decode and decrypt every single one of those settings. But now we have the callback IP address 45.88.186.152. Let's get the other values. Just for funsies, we could see the port, 4782 as that value. We can get the key, worm, nice. SPL, that is Xworm. All right, a little too clear. Group, we could see, Xworm v5.6. USB NM, USB.exe. Install directory, we can grab that. Puts it in user profile. Install string, windata.exe. Neato. Well, obviously, I think the host callback is the kind of most interesting thing. We have that IP address and port, and I think now, we could pretty easily answer that question. Let me take a quick look on census for that IP address, 45.88.186.152. And the census data is interesting. I don't know if this is the most accurate thing, right? The history, though, could tell us a little bit more previously when we would have seen the emails come through. But did it have the port that it would call back to? Or is this maybe a potential redirector? Let's go back and look. There's presumably a lot open, though. Stream, watch live on Rumble. What is this? If I go to that website, is that going to be good, bad, ugly? I don't know. Let's do it. Dangerous site. Yeah? Okay. It says it takes me to rumble.com, but I'm just accessing the IP address. Verify you are human. Is this it? Is this the CAPTCHA, like all along? Please wait while Cloudflare validates your connection. Is this real? What's the source code of this webpage look like? Yeah, I know it's a dangerous site. I'm fine. HTML title here, stream, watch live on Rumble. That's kind of just what we saw. Of course, we had the dangerous pop-up for our browser, and this is just static boilerplate CSS cascading style sheet. But is this the actual Cloudflare, like, CAPTCHA screen, like, oh, validate system connection capability thing? Or is this the fish on its own? Is this the lure that would trigger the actual payload and malware, all on the exact same host that it's calling back to with XWorm? Scrolling down through a lot of this here, let's get to the JavaScript. Here we go. Okay, please wait while Cloudflare validates your connection. Meta key sent false. Add event. Clipboard interaction. Okay, it's a base64 encoded data here. Totally want to take a look at that. Where it does write to your clipboard, fetches the user IP by going to API ipfi.org, detects the Windows key press. Ooh. Oh my goodness. And then actually gets a webhook for Discord, a Discord webhook to validate, hey, this user has done it. The user opened a run dialog box at that IP address. That's crazy. It's like the CAPTCHA hook with a lot more bells and whistles, renders the pop-up and does the, press Windows and R to open the run dialog box, press the verification text by Control-V, press OK to verify you're not a robot. It's the CAPTCHA fish. Wow. Did it go do it? It hasn't popped for me. Whatever, we can see in the code what it's going to end up running. So what is this base64 and the webhook that, we could probably maybe try to do something about? Let's get this base64 though. It is base64 encoded with this ATOB. So let's see what that looks like in our console tab. ATOB will work here. The command is, what the heck? cmd/c, so we invoke the command prompt. Use curl.exe, the now modern built-in, without worrying about certificates and silently accessing kick.im nonsense at squarespace.bat, putting it into our user profile, squarespace.bat, starting it, and then, okay, there's the actual text that's the lure. So what is this? Is this still live? Let me go check. Okay, not valid SSL certificate. That's why curl needed that TACK parameter to ignore HTTPS. Server could not validate that it is kick.am. The security certificate is from friendly that. Okay, let's do it. Oh, it is no longer up. That fish is not able to be retrieved. Whoa, still, I feel like we went full circle. All right, well, next steps are certainly kind of reporting that domain, reporting that certificate, kind of report all parts of this attack chain to help do what we can do to make the internet a safer place. But my goodness, if we're to respond to your email, my friend, I think we have tracked it all down. You have found yourself with a cloudflare.bat potential persistence mechanism some way, somehow, presumably, but post-exploitation getting the point of writing a stage 2 PowerShell script that ultimately drops a payload 1 for AMSI bypass and payload 2 to stage the final, what now I guess would be really stage 4, executable.exe to run the XWorm rat remote access Trojan. Your machine is infected, and goodness, there was a whole lot of damage done from the reCAPTCHA fish shenanigans. I do feel partly at fault for that. Sorry. More on that later in another video, but I think we have reached the end of this one. This was long enough. Hey, with all that said, I hope you had a lot of fun with this one. I feel like we went all over the map between batch script to PowerShell script to .NET assemblies to potential Visual Basic script to even more executable and .NET assemblies to get way back to kind of almost where we started with more stagers of CAPTCHA fish shenanigans and ultimately the XWorm rat. Thank you so much for watching this video. I hope you learned something new. Please do all those YouTube algorithm things, like, comment, subscribe, and do give some love to our sponsor, Vanta. Please give them some love, link in the video description, and tune in for the webinar that I've got with them very, very soon. And one last favor to ask you, if I may, down below in the pinned comments, there is a link to Just Hacking Training. If you'd like to learn a little bit more cybersecurity and stuff like this, you can go take a look at JHT, learn all the cool stuff, and keep up with other stuff that I'm up to with the newsletter. All those links below. Thank you so much for watching. See you in the next video.